Hi, good morning. Thanks so much for coming and keeping me company here in my shop. It's the 10th day of November, and I've been doing a series of what I find pretty interesting tests on this radio. And what I've been doing is I've been basically examining the RF signal flow through the radio and the fact that it doesn't stop where you think it might stop, but it apparently continues right on into the audio frequency circuits in this radio. No doubt it's been weakened by particular capacitors that are in place to decouple circuits from each other, but obviously from the testing I'm doing, it's hardly 100%. The thing about these signals arriving in the audio circuits is you're not going to hear this come out of the speaker. You're not going to be aware that they're there. And are they even consequential, really? Perhaps not so consequential as we might imagine. This radio's working. Its reception is a little weak. Its alignment is probably off by now because I've fooled around with it. So it's probably not aligned 100%. Today what I want to do is I want to look at the opposite effect, or kind of what might be considered the opposite effect. And that is with the signals that are coming out towards the end of the radio circuitry, out of the IF in particular, do they make it back to the start of the radio? They could do this in a number of ways. There are gain capacitors in certain positions to try to snuff out that kind of signal so it doesn't travel back from the output back to the input, which would give us, of course, feedback. And feedback through a radio with automatic volume control in it, as almost all these radios do. The result is often motorboating and some pretty weird stuff. This radio doesn't motorboat, doesn't exhibit any weird things. So as far as I can tell, the problem doesn't actually exist where the output of the IF is somehow feeding back into the input. And have I ever even encountered a radio like that? Well, there could be a lot of subtleties going on that we don't realize. There could be stuff happening, that even sounds coming out of the speaker from these kinds of effects, extraneous or spurious signals getting into the mixer and mixing up with other signals. And another interesting question would be the harmonic of the local oscillator. Could it be mixing with other signals and producing a 455 that can make it through the radio and come out the speaker? That's another one we can take a look at. So first one I want to look at, though, is does the strong IF signal that comes out of the IF circuits make its way back in any proportion back to the start of the radio? And we can do this without the radio operating. In fact, we can't really do it with the radio operating. There's too much going on. So I'm going to flip on my... Oh, it is on. Flipped it off. Put on my signal generator, and I'm going to set the signal generator to the IF frequency, and then I'm going to input the signal generator frequency right at the end of the IF string, where the IF output is, where it connects with the volume control, which can be found handily enough where I've put this temporary capacitor, which is still hanging here. So we're going to put the signal generator in there. This is with the radio not operating. Okay, so I put it around there. Now I have two ways of looking for this signal that I'm going to be putting into the radio. And one is to use my signal tracer, which I fooled with at the end of the last video, or continue on by using the SDR radio, which I think I will. I think I'll continue with the SDR radio because it has the frequency display, excuse me, and it reveals a lot more about what's happening with the radio. Now the signal levels are going to be relatively low here. No, that's not it. That's not it. Here we are. So I should be able to hook this up directly. Of course, I can control the signal level coming to the radio from my signal generator over yonder. And to put this, well, we could start with the grid of the mixer tube. And the grid on the mixer tube, I dare not rely on my memory. It's a 12SA7. Okay, I can rely on that part of it. 12SA7. So the grid of the 12SA7 is pin number 5. That's the signal grid, pin number 5. So we'll take a look at that. Pin number 5. 1, 2, 3, 4, 5. What's it right here? So that's now connected to the antenna input on my SDR radio. And we could potentially, you don't have to turn the radio on, nothing has to warm up. It could be doing stuff already. I'm going to take a look. Okay, so the antenna from the SDR is connected to the grid of the mixer tube, the signal grid, and I'm just going to touch it with my finger. You can see it's definitely sensitive there. The red line is marking 460 kilohertz. That's the IF frequency, and I am currently feeding in a pretty strong 460 frequency or signal rather, where into the input side of the volume control. I could put it that way. So I'm trying to imitate what the radio itself does. I don't know the relative strengths here. Maybe my powerful signal generator is weak in comparison to what this radio is doing with its IF signal. I don't know the relative strengths. So I don't see anything. Let me just check calibration here. Okay, I'm going to move the signal generator frequency up and down a little bit in the hopes of seeing something. I'm looking right around the red line. There's nothing showing up at all. Okay, we're going to go to maximum. Oh, there it is. Okay, so this is a strong signal. Let me just wiggle it a bit. Yeah, there it is. Put it right on the red line. 460 is what my signal generator frequency counter says. So there we are. So there's a bit coming back. And that's actually quite a small bit coming back. What have I proved here? Not too much yet, because I'd have to add or subtract capacitors from here or there and see what kind of difference it makes. Now I've replaced the key capacitors in here already. Okay, that clears things up. Well, suffice it to say, of course, some signal can be picked up under these circumstances. Now, it could be just my lead. Let me just move the leads. Look at that. So what I've done is I simply separated the signal generator lead. I'll show you in a minute what I actually did to do that. And I'll just put it back together. So look at that. So this is a false test. So in doing this, we see there's virtually nothing making it back. And I guess that would have to be the case, or the radio's gonna misbehave something terrible. Now, it would have been very interesting to perform this test before changing any of the capacitors, or when I removed the one capacitor, the AVC capacitor, briefly ran the radio. There was all kinds of problems in it. I'll bet you this level of feedback would go way up. Now, what I was doing was initially the wires were like that, and I was seeing an effect on the SDR, and I just took them and did that, and the effect went away. So, in terms of going through the radio, no, not happening, at least not the way I have this connected. And I'm pretty sure I got this right. We could look at grid number 1 on the 12SA7. That's carrying the local oscillator frequency. Why don't we just take a peek at that? 12. That to me is very unlikely to have signal on it, because I believe it's fairly low impedance. So yeah, weak signals just aren't going to push the voltage around in a low impedance circuit. So we want to look at grid number, I am on grid number 1 right now. Okay, we're going to switch to grid number 3, which is pin 8. Okay, so I'm going to go back to the SDR, and we'll move this lead to pin 8, and we'll see if there's any, did we do a comparative thing? Okay, I'm going to put the wires together. There's the signal. Wires apart. I'm going to disconnect here. Just putting the wires near each other. Look at the signal go through there. And now attach this to pin number 8. Okay, so the SDR is now on pin number 8. The wires got close together. I'll separate them. It looks like there's a little wee bit there, but you know, based on this, we can't be sure how that signal is getting to the SDR. It could be through the air, because obviously I put the wires close together. Bingo. Okay, not the best test, but I think what it does show is that the amount feeding back is very low. No surprise there, and kind of outside the scope of a measurement like this, I think. Okay, I've got some more ideas of things to do here. I'm going to set up for the next thing. I think I'm going to get the sweep generator going on this radio. Okay, so I still have the radio switched off here. I have the sweep generator running. This is a sweep generator. It's sweeping between 440 and 480, and in between the middle is 460, the IF frequency. So it's sweeping a range of frequencies through the IF. The output of the signal generator is hooked up to the grid of the first tube, which is kind of interesting because the radio is not switched on. You'll see why it's interesting in a minute. So this is really set up for having the radio operate. The antenna for the SDR we're going to be looking at is connected via this rather long lead for the resistor, capacitor, and then to the top of the volume control, input side of the volume control, which is the output of the IF. I guess after being rectified, I guess that would be part of the picture there. So, oh, I wonder what just fell on my bench. That's another one of my buttons from my machine here. He's lost a tooth. But thank you to a kind viewer some time ago sent me another one of these machines. And so I have more of these buttons. Anyway, not to talk about that. So, what's going on here with the radio not operating? It's kind of interesting to look at. Let's do that. So all the action, the sweeping action, is in the IF, down in this area. I don't see anything because I think I've got the power down low. Okay, we crank it up. There it is. Now it's sharp-sided. It's not a response curve. Not at that size. It's sharp-sided because that's where the sweep stops. Now I can extend the sweep downwards. Downwards. And I can extend it upwards. So that's a pretty broad sweep. So there's no sign of any kind of resonant circuit or anything affecting that I can see. That's probably just interference. Again, I got my wires a little close together here. Let me just separate them all. That's exactly what it is. It's just the way I've got the wires here. Okay, let's sort that out. So, see, I've got them just kind of crossed. And they really shouldn't be. So if I swing this over here, I can separate them more. Bend this guy up and out. Like that. And I'll just take a peek at the SDR. So what I've done is I've discovered a accidental circuit, RF circuit, that's going to interfere with the test I'm doing, and I've eliminated it by obvious means, moved the leads apart. Okay, I'm learning as I go here. Good show. We're going to turn this on. Let me put the SDR back up here. Okay, so all the action is happening down here. I'm going to zoom in on that area. Let's go on, let's leave it like that. So we're still on 460 with the red line, and I'm sweeping from somewhere down here to somewhere up there. I don't know where right now. Oh, in fact, we can find out. Let's find out. Oh, we can't see it. How about I blast it? Kapowie. Okay. So now we can see the extent of the sweeping. Now see how it's jumping around? That's the effect of the SDR, which is really designed to look at one single frequency like any radio and detect it and play it out the speaker. It's not designed to do this kind of stuff. But if we get rid of this SDK, look what it'll do. Eventually it collects all the peak amounts all through it, and it turns into that kind of thing. Isn't that fantastic? And I can just refresh it if I just bring the decay on briefly and then put it back. That's going to enable us to see the shape of the IF once I start to sweep and once I turn the radio on. Now I'm going to turn down the input level until we can't really see. Oh, I need some decay to see it. Can't see it decay that way. So there's no evidence of the signal there now. So there's no interfering sort of signal path. I'm going to switch on the radio. I'm going to let you continue to watch this. Don't know what's going to happen. There should be no smoke involved. Here we go. Okay, so the radio's warming up now. I'll turn the volume up so we can... Oh, no, the radio's not even switched on. The radio's switched on now. Turn up the volume. See what happens. Boing. So the buzzing sound is the sweep passing by the tuned point of the radio. When it does that, there's a signal converted to 460 going to go through the IF and come out the speaker, but it's just a blip. Let me slow this way down. It's going to look a little crazy on the so that's what's actually happening, only very fast. And we're just looking in the IF. We're not looking at the whole radio here. That doesn't even make sense what I just said. I'm going to speed it up again. And what I'm going to do is get rid of the decay. Get a nice, beautiful shape eventually. So why isn't it dead on 460? So it's very tempting now to start realigning the radio a little bit and try to put that peak right on 460. But I don't have complete faith in the approach I'm taking. I don't know for sure. I haven't, by hooking up this equipment, I haven't thrown the radio off a bit. Let's think about that for a minute. You know, I don't think this is throwing the radio off a bit. I'm picking it up at a low impedance point where I know from experience, earlier experience, it didn't do much to the radio. Feeding it in to the grid of the tube, everything before that, what does it matter if I disturbed it? It doesn't matter. Okay, so what I'm going to do, I'm going to stop, rearrange my cameras, and we're going to tweak this based on the SDR image here. Okay, what have I got happening there? So on the right side is a meter showing the ABC voltage. Now let me just reduce the signal input to the radio, and you'll see the ABC voltage drop. Okay, let me just see, am I crashing against the top? So I'm going to boost the signal way up. Well, I'm not crashing at the top. So I'm trying to put in like a signal so high it's just pushing the radio to its limits. I'm detecting that by not seeing the meter go up further. That's not the case. The meter can go up further with more energy. I think we're okay here. I don't want to be overloading the radio too much. Another thing we could do actually is I could reduce it and watch the shape on the SDR. Does it drift in frequency? So that's interesting. So you see now it's pretty much dead on. The signal is so low you can't really hear it. Turn up the radio a bit. It's gone off to the right a little bit, so that's too much. You're supposed to do all this work with the least signals possible. There's still lots of sound coming out of the speaker here. So, is there any adjustment needed there? I think I set myself up for nothing. It looks to me like to be perfectly fine at 460. Okay. There's nothing to adjust here. Well, that's good, because I did do the alignment earlier, and as quickly as I may have done it, it seems to be fine. Okay, so now what we want to do is we want to broaden out the sweep right through the regular broadcast range of the radio, no longer targeted on the IF. And let's see, I could just I should put the signal in through the antenna. That makes the most sense here. I could leave it where it is, but let's not. So this is the signal generator signal. Trying to make it over to there. Don't really need this. Okay, let's do this a little differently here. I don't like to do this. I'm going to put a clip lead on here. More and more wire to cause extraneous signals. Okay, we're going to go in here. Yeah. How come that's showing up on the... What is showing up there? That's just regular IF stuff showing up. Let's make sure of that. Absolutely sure. Okay, sweep generator's turned right off. So that ticking you're hearing is the interference that I hear all the time in here. And then you can just see stuff rolling through the IF as I tune across. Hey, can we pick up a station? Why not try that right now? Way down. Way down around here somewhere. No. Oh. No. Should be up in this area, actually. No. Okay, we won't worry about that. So the sweep generator, I'm going to hook up to the antenna. None of it seems to be coming. Of course, it's very low. Let me turn up the strength of the sweep generator. I'm looking to see if putting the IF frequency in to the antenna here is going to make it show up. Let's give it a blast. Oh, you know what? I never had. Sweep generator was not switched on. I left it on. Let's turn it on. Okay, now I'm going to crank it up. Oh yeah. Oh yeah, there it is. So that's the sweep going in through the antenna and making it back to the same grid, but going through some tuned circuits on the way. I've got enough juice to overcome it. Now we've got to set this. We want to start sweeping around 500. So here's how we do this. We set this to start frequency. You may not be able to read it, but it's on this. We adjust this until it says 510. Okay, 510 is good. And then we want the stop frequency, do that, to be up around, oh, okay, I can't do it quite like this. I'm only going to get halfway up. I want to do the whole band. I got to do this, I got to do this. Sweep start frequency. This gets a little tricky now to set. 540. Okay, well, we'll go with that. 540 is one limit on this device, the way I've done it. And we want to put the stop frequency at around 17. 100, 16, 18. It's going around 1700 or so. Okay, 1700, there we are. So I do this. There's now a signal sweeping through the entire AM band going on the antenna. It's sweeping at a fast rate, but almost no signal there. So we should hear the sound of the sweep passing by the tuned point of the radio. If I turn this up, there it is. Okay, we don't really want to listen to it. You'll see the AVC voltage going up also. Even though most of the time the sweep is sending over a frequency that the radio is not tuned to, for a moment the sweep passes the tune point, and at that point there's an output from the IF which then drives the AVC voltage slightly. So that's why the meter is going up a little bit. Okay, what are we going to do? So we don't want to look at the IF. Well, we could, but I think it's more interesting to look at the entire band now. And this might take a moment here. Let me shrink this down. The entire band. Not quite. Shrink it down some more. Okay, so the entire AM band is running from here over to here. Here you can see the IF signal. It's coming out very strongly, and that's because that's where I'm looking at it with the SDR, right at the output of the IF. So no surprise there's a strong signal there. The radio is tuned currently to around 600 or something like that. So add 460, you get around 1,000,000. So this is probably the local oscillator right here. So again, it's a large signal compared to everything else. Let's tune the radio a bit and see it wiggle. There it is. No question. Now, there are some other signals in here. These are all in the way of what I'm trying to do, but could be when I crank up the sweep, the AVC will come up, those things will go down, and in the end we'll be able to see some stuff more clearly. So let's try that. I'm going to crank up the sweep here. There we go. That was a sudden increase, a sudden decrease. Well, that's interesting. What is that thing? What is this, and what is this? And maybe even what is this? You know what I'm guessing it is? This is 460. You double 460, you get 920. This is at 920. And this will be 3 times. And I can't do the math, but that's what it certainly is. And this would be 4 times up here. Now, is this in any way significant in the radio? Well, we know that what's here will make it into the audio circuits, but won't come out the speaker. Just from earlier experimenting. But this is not what's really interesting. What's really interesting is looking for a little response curve down in this area. I don't see anything. So I'm going to tune the radio a bit. Oh. I don't even have the volume turned up. Let's turn this back. Back. Put it like that. Okay. So the radio is now tuned to, hard to see, around 900. So what I would expect, well, that's a bad spot because of this. Let me tune it down a little bit. Okay, maybe that's 700, I'm not exactly sure. Well, we can figure it out from here. We know the local oscillator. It's 11. Let's set the local oscillator because I am just so mathematically hampered. My father was a high school math teacher. Would you believe that? So now I'm going to force a local oscillator under the red line. The local oscillator is now at 1200. Subtract 400, get 800, subtract 60 more, 740. The radio's tuned to 740. Okay, so we're going to put the red line on 740 right here. So I would expect to see a response curve here from the front end tuning of the radio. We're going to give it more power on the sweep. Don't see a thing. Okay, we're going to give it a lot more power on the sweep. Okay, can't make the radio any quieter. Interesting. So I now have the sweep generator running at full output power. I can't raise it anymore. It's limited. But look, you can see the response curve here. And it's exactly where it should be. Now we're going to tune the radio around. Okay. Well, wait a minute, I better look at the dial. The dial says, but you know, it's 740. Right on the money. So, okay, that's excellent. This means, quiet down this thing here. Okay. Whoop. Well, that's got it quiet. I just cut the signal to make it quiet. So what that tells me is local oscillator, IF, and front-end tuning and pointer are all working properly right at this particular frequency. Right on the money. Okay, so I'm going to turn the sweep on again and we're going to tune the radio up. We're going to watch that little response curve do its thing. That's this one here. This little curve here. As I tune up. Okay, here we go. You can see the response curve moving upwards. Okay, it's getting mixed up with that hump. Some interesting sound came out of the radio at that point. Okay, we're going to tune up right in here. So there's nothing else really there. Okay, I'm watching right here. Frequency is 1050. Let's make it exactly 1050. Okay, so we think the radio's tuned to 1050. See, that's a loaded question now, isn't it? What's the radio tuned to? Well, what do you mean? Do you mean the dial pointer? Do you mean the local oscillator? Do you mean the antenna? I'm trying to show you where it's actually tuned. So that would be, so it's right on 110. You can't see it, but that's actually 110. So it's tuned to 1,080,000. 1,080,000. According to that exercise. Now I'm going to check myself because I want to make sure. Yep, that's 1080. The front end tuning is at 1050, 1080. Watch the red line here. I'll put it where it should be. So this tuning peak should be up here, but it's down here. I think that's off a significant amount. Let's go up around 1500 now. It's got pretty quiet up there. Okay, so what I'm doing is I'm looking at the SDR and I'm setting it to 1500. The peak to me is centered on 1500. And when I look at the frequency involved, it's 1550. So it's close. I think the size of the peak gets broader. It's covering more frequencies as you get up higher in frequency. And the local oscillator is out here. Okay, so if we were tuned to 1500, let me actually tune the radio to 1500. 1500. Okay, according to the dial. I have to say that, don't I? So there we are. Well, wait a minute. That's not where we are. 1500 is here. Yeah, 1500. So the peak is low. Now let's see if the radio is actually converting 1500. So if we're at 1500, we should go 460 above 1960. That was a good year, 1960. I don't really remember it. So here we are, 1955. And what did I say we should be at? 1960. Didn't that what I say? Look at that. It's almost dead on. In fact, I could squeak this up. And I mean, really, it's very, very close here. So the radio is doing well at tuning in 1500 when the dial says 1500, except the front end tuning is off. So I'm going to adjust this with the sweep going. I was going to say we can watch the AVC change, but with the sweep going, that's not quite right. What would be better would be to switch signal generators, put in exactly 1500. Let's do that. Okay, so I'm going to switch things around a little bit. Sweep off. Going over the other signal generator here. Would be this guy here. Where? There. Okay, so 1500 on here. 1500. Go here. We're almost there. Radio volume up. Signal level low. No. Yep. Okay, watching the ABC voltage. So there's an interference signal there, making it a little tricky there. 1500 is not a good spot. Well, it's hard to tell, but I would say that's where we're actually tuned. 1495. Well, that's really close. I mean, that's really close. Now, is the ABC reflective of this signal generator strength? So I'm going to fiddle with the output level on the signal generator here. So yes, it is. Higher and higher, and down, lower and lower. Okay, so the meter on the screen is following the AVC, which is following the signal I'm using. Okay, so we're basically pretty close to 1500 here, close enough. We're matching the local oscillator. I am now going to tune the front end of the radio here and try to maximize the reading on the, because we're not using the sweep. You can't see this in a sweep way, but here we go. Down and up. So I'm moving that bump we were seeing right on top of 1500. Oh, my meter is having an effect here. That's not so good. Let's try a different. My meter, my screwdriver. Okay, this one's a little better. I think this looks like aluminum to me. Aluminum? Can you make strong enough screwdrivers out of aluminum? Let's find out. No, not aluminum. Okay, now I've aligned the radio as best I could using the sort of the classic signal generator technique just now. Let's put the sweep back on and go back down to the low end and see what's happened, because I think we're way off on the low end now. So sweep back on. can turn off the decay here for a moment. You get a better look at the shape of it. Look, it's bang on 15 now. Okay, so I'm going to tune the radio down. We need the decay going a bit to see it. Tune it down, and we'll do this at 6 or 700. Okay, that's 700. I can't get rid of the sound out of the speaker, although I sort of could. Now what's happened here? This is the bump right here. What I got is a funny squarish shape here. Don't know why. I think this is the bump. It's not on 700. Let me tune the radio a bit and just watch that bump move. That's definitely the bump. It's not much of a bump. Okay, tune it back to exactly 700. So it's 700 on the dial, but what is the radio really tuning? So this is the local oscillator. Let me turn this down again. There. Wow. Okay, it only takes so much of that. So the radio's tuned here. That's 1142. You know, I'm going to use my calculator. 1142. Okay, so we're going to go 1142. We're going to take away 640, 460. 682 is where we are currently, is the signal that the radio is converting to 460. So we're actually tuned to 680. There's a station at 680. But we're not really tuned there. In fact, I can just grab this camera right here. Take a look at it, for crying out loud. It's supposed to be 680, but look, it's 700. Let me put it this way. When the radio says it's on 700, it's really converting 680. Now, where is the peak? Where is the peak gone? Oh yeah, this is off. Turn this back on. Where are you? I can't see it. So I think what's happening at this point is I'm overloading something somewhere. So we are seeing something right around here. And I would say it's, except for 680. 680 is right there. So the way I would interpret this is in this radio, the local oscillator and the front end tuning are tracking together properly, but they're not matching the dial. Something I've realized most recently is that this is a better situation than what I used to try to force, which is for the dial to be accurate. And in some cases, I think in doing that, I was forsaking one of the other two factors. Local oscillator wasn't going to be correct, or most importantly, the front end tuning. The radio not correct, and then the performance goes down. Yeah, okay, so the dial's accurate, but there's nothing there to hear anymore because the radio sensitivity has been knocked down. And I think a lot of what we're looking at here is what a person is getting at during the alignment when they do the rocking thing, which I've never really appreciated. Rocking, I think, is the wrong word for it. In all the radios I've tried that rocking thing, I've had one where it made a huge difference and ended up being an excellent performer, and it wasn't a radio more advanced than this one. So that is still burning a hole in me to this day, why that one radio just came to life like crazy. So now the next question would be, well, is there anything more to be gotten out of this radio? So to me, in doing this, and I haven't done this to enough radios to really be able to quantitatively compare them, this seems like a pretty weak response on the front end. A bigger response on the front end would clean a lot of things up in here. What would be restricting that response? And what is the response actually coming from? I think it's pretty simple. It's the antenna, and I'm feeding this in, and I think what's this capacitor doing? Let's take a look. This is the last lone original capacitor I've left in here. Let's take a look at the circuit diagram for a sec. Oh, I can do that fairly easily here just by doing this and then doing this. There we are. Okay, that's good. Okay, so the front end tuning is comprised of some kind of antenna. It'll have a capacitance to it. This coil, which, it's a coil, so it has some effect. If this capacitor, this is the one that's on the back of the radio that I was just pointing at. So what if this was weak and not doing its job? Like if I cut this right out, suppose this wasn't even here, it was open circuit here. Well, you wouldn't get much action at all in this coil. You have virtually no action. So this is fairly important capacitor. Is there a problem with it? Almost certainly not. I mean, it looks great. It's in a place where it's not under stress. So, but maybe this guy is weakening the whole input signal, because this ground is not as strongly attached as it could be. We could just short this briefly. What would that do? That wouldn't cause any problem. That simply hooks the antenna up to the chassis and introduces the safety issue that all these radios have. But it's me here with an isolated cable. I can just short that guy out. Okay, so that's part of the picture. Okay, so this is the tuning capacitor and its trimmer, which I was adjusting. Well, that's it. Unless these coils themselves, now this is the actual antenna on the back of the radio. Can these coils somehow lose their cue? I don't think so. I mean, there could be a defect in the coil, like an open circuit or a short or something, but that's not very likely either. So the only thing that's really here to fool with is to short this capacitor out and see if the radio doesn't get stronger from a signal. Wait a minute. Now, just stop and think for a minute. Yeah, I'm feeding a signal in here, but normally the signal is just being picked up in this coil. This is a little. Wait a minute. This is different from. So this can't be the pickup coil. The pickup coil in a loop antenna is tuned. This would be the pickup coil. And then what's this one doing? It's not doing anything. It's just sitting out here. This is not the way I imagined. This is more what I'm used to here. This kind of arrangement. We're not going to study this. This looks like a single coil, no transformer. So I'm not even used to this. But you can make this coil resonant against these capacitors at the frequency of interest. And this antenna doesn't really have a ground, or does it? Not that way. This way. Through this. Down to here. It's a very different approach. So I think we could remove this, like there is no antenna on the radio. Yeah, I'm feeding a signal in here. But let's just pretend this radio is a normal use, sitting on a table, no extra antenna connected. Couldn't you just rip all this out of the radio and get rid of it, and there'd be no change in operation of the radio? It's all up to this guy, who is made resonant with these two capacitors, the main tuning capacitor and its trimmer. So who cares about this? If you're not using the antenna, who would care about this? And this is just 0.05. There's nothing precise about this. I think it's 0.05. Oh, we don't know for sure. Can I see it? I cannot. It's a Cleveland condenser, but I cannot see the value of it. Well, we can still short it anyway, because that's how you find out you're totally wrong. That's what science is all about. Science is actually not about finding answers. The main thing is finding questions. That's what science really does. It raises questions. Endless questions. So that's my question. What happens if you short this when the radio is operating normally? Now, I input signal hooked up here. Maybe that was preventing this coil from picking up the radio station I was trying to pick up. I don't think there's much I can do here to improve this radio. I don't think there's anything here that you could do that with. There's nothing here. We'll short the capacitor. The signal's coming in here. We might see a difference. We'll disconnect everything, try to pick a station up, and short this capacitor, and it can't make a difference. Can it? I don't think so. Okay, that's the plan. Oh, that's right. I don't have to switch cameras here. Fantastic. Okay, so what did I just say I was going to do? So I'm going to short the capacitor and see what happens with the signal being fed in through the antenna, external antenna connection, I guess is what we could call that. Just get myself a nice clip in here. Okay. Checking the she's good. She's good. You could do this with a little piece of wire instead of a big long clip lead. Okay, so watching the AVC meter. A puny difference. Okay, let's pick up a station. Yeah, having that hooked up there was making a big difference. It's still coming. Okay, turned off that signal generator entirely. Okay, tuning in and out of the station. Watch the IF frequency area on the SDR, which is down here, as I tune in the station. So there's some noise right with it. My guess is I take this out of my shop, take these wires off, take it out of my shop. It's actually working quite well. One last experiment. So we know the local oscillator has harmonics. No surprise. local oscillator is usually very, very strong, and generating non-linearity or nonlinear operation in the vacuum tube helps with the signal mixing process. So I believe in a lot of these radios, the local oscillator is slamming the mixer tube with a signal. Now, there is I'm tuned low in the radio. Tuned low in the radio. Local oscillator is low in the radio. There are two effects. One is you can go 460 above, and if there's a signal there, it may come through. We're going to check that. But then you can also go double the local oscillator, so it would be 920, and anything within 460 of 920 up here, to be 1360, might come through. Because, yeah. Okay, let's check these out and see what's going on. These are images, I guess you could say. I've never read much about the harmonic from the local oscillator, but I certainly read about the image. So we'll go after the image first. So I'm going to tune this slightly off. There. So now the local oscillator, where are we on the dial? Okay, so on the dial, we're at 680, so we're really around 6. No, we should be 590, 580. We're around 570. 570. Oh, these are tough numbers to add. 570. What's that? 1030. I don't know. 570 plus. I can just look on the SDR to find out where the local oscillator is. Plus 460. But let's keep doing this. I like to do things 1030. 1030. Okay, looking on here. Here's the local oscillator. 1030. 1032 is what it actually says. Well, excellent. Now, if there was a signal, so take 1030, add 460 to it. You use this calculator for a while. It gets full of numbers and the buttons get really hard to push. 1490. If we feed a signal 1490 into this antenna, we might hear it. And I just happen to have a 1490 pretty handy right there. Right there. Okay, so we're going to take and borrow this cord over here. That's it. Pull down the whole bench, Jim. Go on here. And feed this into the antenna at the back. You hear it right away. There was a click there. I don't like that. So the question is, when the radio is intended to tune 570, does it also pick up something at 1490, somewhere around there? That's the question. The answer is yes. This is not a very powerful signal. This is kind of an average strength antenna signal. There it is. Now it's suppressed. I'm sure if we just dialed this down to the proper frequency and fed it in, it'd be a lot louder because it's suppressed. But now the next question is, what about the other harmonic? So think about this. This is making my head hurt. So we have a local oscillator at just around 1 million. That means there'll be a harmonic around 2 million. Look on the SDR. There's the 2 million mark up here. Do we see it? Let me tune it a little bit. Where is it? I don't see it. What are we looking at? We're looking at the output. Could be the signal just can't be seen the way I got this thing connected. But we can bet there's one there. That even makes sense. Well, let's just roll the other signal generator right up. No, so if there's a local oscillator signal, it'd be 2,060,000, somewhere up like that. It'd be just right on the edge here. I'm going to move this over this way. This wrecks everything here. Okay, 1030. So that is the local oscillator, and we're expecting it to be also at 260. 260 is somewhere in here. Let me tune a little bit. There it is. I see it. Okay. Put this back. So it was. I looked away. Doggone it. No, I know where it is. It's right here. Okay, I'm going to put the red line on the harmonic of the local oscillator. 260. There it is. Now I want to swing another frequency in, 460 from 260. Hey, there's some easy math there. 16, just around 1600 below. So if there's a signal at 1600, is that right? Yeah, I think that's right. Okay, 1600. What do we hear at 1600 now? Oh, yeah, 1600. There it is. I mean, I can make it a lot more apparent. Juice this up. So, if we were trying to pick up a weak signal at 570 with this radio, a faraway station we want to hear, 570. Meanwhile, there's a powerful station at 1600, which there isn't, but if there was, or it could be a noise signal, that would come through the speaker, and we would think we're hearing it where the radio is tuned to. This is the whole point of this. Whole exercise is about, getting a grip on what's really happening in these radios. Well, it'd have to be a pretty strong signal. The signal I'm using now from the signal generator would represent a very strong signal from an antenna. I would have to think the better the radio, the less of these effects are apparent. But this one's kind of a minimalist radio, which is one of the reasons why I'm doing all this with it. Because I'm going to be doing two helicrafters in a row next. First one is a step up from here, and the next one is a step up from this one. And along the way, we're going to repeat all these tests, find out what really goes on. Do the better radios quell all this stuff and get rid of it? Or is really what's going on is that this radio can only hear 460 kilohertz coming out of its IF. That's all it can hear. It's all that's going to come out of the speaker. Meanwhile, there's all kinds of signals flying around just outside of that we don't normally hear. And then even more that are being accidentally converted to the IF frequency by harmonics of the local oscillator. And we haven't explored this. Even just, unnatural signals. Interference signals coming in and acting like the local oscillator. And so if you have an accidental signal at, say, 1 million, and you have another accidental signal 460 kilohertz away, and they both get into the IF, or into the mixer, how does the tube know the difference between the local oscillator and the antenna signal and these two? It doesn't. So if that exists, anywhere you've got two signals 460 kilohertz apart present inside the mixer tube, an effect will be heard in the speaker. In a world where there's no interference and no spurious signals, none of that stuff happening, none of these issues are important because the effect wouldn't present itself. And that's what it was like when these radios were made. The big interference then was ignition noise from cars. Okay, I beat the heck out of this radio. I don't think there's anything more I can do to it to improve its operation. I think the alignment is as good as it's going to get. I think we verified all that in a couple of different ways. I think I'm done on this guy. Except I still have to prepare to sail the high seas with the rest of the radio, right? This is where the money is. In this cabinet. The ship cabinet. Fantastic. Okay, well, so I think that's it for electronic work on this radio and the cabinet stuff and all that. It's just a matter of cleaning and figuring out how to power some lights in it. And we're good to go. Thanks a lot for watching. I think there'll be a different radio on my bench come the next video. See ya.